black holes come from? Do stars live and die like us? When will our sun die? Will it turn into a black hole? What will your fate be if you happen to fall into a black hole? Come along with me on a breathtaking journey to understand the amazing history of the cosmos and to explore some of the universe's most intriguing places, right from a massive supernova to black holes and beyond. Welcome to the second episode of the Grand Cosmic Story.
Are you curious about the world around you? Do you wonder what else is out there beyond our world? Dr. Latha Christie, a scientist and an author, will take you on a journey through the universe. Join her in exploring the universe through her web series, The Grand Cosmic Story. Stay tuned to find out what today's episode is all about.
In this vast cosmic ocean, each and every tiny dot of light that you see is a huge galaxy. If you can ask each galaxy to write its autobiography, it will write the story of the birth and the death of the billions of stars within it and even their new lives after death. Yes, stars and galaxies live and die just like us. Right now, many stars may be facing colossal death. But who is in control of this cosmic game? What is driving the birth and death of stars? It is gravity, the same gravity that helps you to land on the ground when you jump up instead of floating off into space. Gravity's pull on an object decreases with distance and increases with mass. That is why we are orbiting round the sun and the moon is orbiting round us and not the other way around. When gravity acted upon the early universe that had plenty of gas, mostly hydrogen, over time they turned into stars and galaxies. But how do we know that? Scientists learned the stories of the stars and galaxies by peering into the sky, observing bright objects day and night through sophisticated telescopes. They found that stars form when an extremely cold molecular cloud of dust and gas, mainly hydrogen, clump together because of gravity. When the cloud tries to disintegrate, gravity pulls them back, makes them denser and denser until a region of condensing matter begins to heat up. When the temperature increases to a few million degrees, nuclear reaction starts at its core, fusing hydrogen into helium. Stars are giant nuclear reactors. In the core of a main sequence star like our Sun, energy equal to that of 15 billion nuclear bombs is produced every second. And that is the reason for the heat and light from our Sun. The heat of such powerful nuclear reactions in the core of the star produces enormous pressure that balances the powerful force of gravity which tries to collapse the star, and this keeps the star alive. Over time, as the star consumes all of its hydrogen, the core of the star starts to shrink, while the outer layer starts to expand and gets dissipated into space, and the star starts a journey towards its death. Stars die in two different ways. While some die a gentle death, others face a violent death. How does a star die? With a whisper or a bang? How will our sun die? Astronomers say that our sun will face a gentle death. It's about halfway through its life. After about 5 billion years, when it will burn the last of its hydrogen, a life giver like our Sun will become a destroyer. But long before that, all life would have faced death because of the increase in the heat of the Sun. When our Sun runs out of hydrogen, it becomes very hot and starts to fuse helium into carbon and oxygen while increasing in size to around 100 times. At this stage, it turns into a red giant star, and over time, the super hot core shrinks and becomes a white dwarf star. But a massive star, more massive than our Sun, has a different story to tell. Such stars face a violent death. When such a star runs out of its fuel, it gets heated up and starts to fuse carbon and oxygen, and then heavier and heavier elements, and finally iron. Once the star starts to fuse iron, it starts to absorb energy instead of producing energy. Within a few seconds, the whole star collapses and explodes violently. This dying gasp of a star is called a supernova. It's a spectacular and the biggest explosion that you can ever imagine, with the light coming out equivalent to that of the brightness of around 1,000 of suns. Such explosions eject all of the iron and the other heavier elements like carbon and calcium that we need for life to exist into the interstellar space. That is why Carl Sagan said, the nitrogen in our DNA, the calcium in our teeth, the iron in our blood, the carbon in our apple pies were made in the interior of collapsing stars. We are made of star stuff. This statement is only partially true. We are much more than a mere stuff. We have a mind to reason out and think, and we have a soul to love and to admire beauty and to realize how we came into existence in this planet. Sometimes the core even survives such a powerful explosion and ends up in two different ways. If the surviving core is less massive, it will end up as a neutron star. But if it is more massive, it will end up as a black hole. Interesting, isn't it? A neutron star can sometimes become a pulsar that rotates rapidly, emitting regular pulses of strong radiation. On the 4th of July, 1054 AD, astronomers in several countries reported an eye-catching event. They saw a new brilliant beacon of light that blazed in the sky. It was visible for almost 2 years, shining so brightly that it could be seen even in the daytime. What our ancients saw was the supernova explosion of a massive, hot, giant star. The light of that explosion had traveled around 6,500 years to reach the Earth. The debris of that explosion is called the Crab Nebula, and at the center of it lies the Crab Pulsar that is endlessly fascinating. It rotates about 30 times each second, sending powerful beams more energetic than medical X-rays. If the surviving core is more massive, we get a more interesting end product. The huge gravity due to the mass crushes the core from millions of kilometers to a few kilometers in just a few seconds. This increases the temperature to as high as 100 billion degrees, blasting off the outer layer in a massive supernova, while the core crushes itself to a single point within a boundary called event horizon. A black hole is now born. A few years back, ALMA radio telescope in Chile in South America spotted a black hole roughly 100,000 times as massive as the Sun at the heart of a supergiant elliptical galaxy called Messier 87, 55 million light years away from Earth. Astronomers started to build a network of telescopes spanning across many different continents to picture this black hole. Finally, in April 2019, the giant telescopes could image the event horizon of that colossal black hole, which earlier people could only see in movies like Interstellar. Have you ever wondered how astronomers could picture a black hole that does not emit visible light? A black hole can literally light up the surroundings as long as it can gobble up the surrounding matter by converting the energy into light. The surrounding materials are either sucked into the black hole or flung away in a jet at nearly the speed of light because of the powerful gravity of the black hole. The gravitational pull of a black hole is so strong that it not only bends the path of light, but it also keeps the light from escaping like a cosmic trap. That is why, when you end up near a massive black hole, you will start moving faster and faster due to its gravity, and finally, once you go past beyond its event horizon, you will be smashed into your point. If you are still alive, you can do a little bit research to find out whether the time is running backward inside that black hole, or you can meet Einstein there to learn about backward time travel. But the problem is that you cannot write home about your experiences.
Tars, will you read me over?
Can you see the power of gravity behind these cosmic events? Gravity is powerful enough to transform a meaningless soup of gas into a beautiful star. Gravity is also powerful enough to collapse that star in a supernova and turn it into the elements that are needed for our life. Stephen Hawking feels that gravity could be called the hero of the universe. He says in his book, The Grand Design,
because there are laws, such as gravity, the universe can, and will, create itself from nothing. Spontaneous creation is the reason there is something rather than nothing. It is why the universe exists, why we exist. It is not necessary to invoke God to light the blue touched paper and set the universe going.
do you agree with this statement? Let me give you an illustration. Recently, drones are impacting our society a lot, right from fighting a war to tackling everything from disease control to search and rescue operations to delivering pizza and many more. Can a hiker who was rescued by a drone from a dangerous ledge on a mountain feel that the drone is the reason that he exists? Is it not more likely that there was a pre-existent intelligent being who designed and programmed such a drone to carry out the search and rescue operations? In the same way, can a blind force such as gravity bring about such an astonishing universe that I just described? Can a blind force be the hero of the universe? Or is there somebody behind it who brought that force into existence? Think on these two important questions until we meet again in the next episode. How did this one-time beginning come into picture? Who started it? Is it a product of time plus matter plus chance? Or is there an intelligent design involved?